Good day. I'm Martin Gagel with Market Radius Research. It's Thursday, October the 20th, 2022. We've got CEO Leslie Klein of CCOM Satellite Systems. CCOM is a world leader in the design, development, and manufacturing of mobile satellite antenna systems. I'm very glad to have Leslie join us today. CCOM is a true Canadian success story, being one of the world leaders in mobile satellite antenna systems, doing this profitably and even paying dividends consistently over many years now. Company just released another strong quarter for their recent Q3 results. CCOM has a strong base of business from its existing products line and is working on some revolutionary new antenna technologies. I'm looking forward to figuring out the runway for its legacy business and the opportunities for its new phased array antennas. But please remember, this is neither recommendation nor investment advice. We're here to learn about the company. Leslie, thank you very much for taking the time to chat with us. And please tell us about CCOM.
Thank you for inviting me, Martin. It's a pleasure to meet you virtually. And I'm happy to tell you about the company. If you want to move the next slide.
All right, standard disclaimers and the overview.
Right. So the company was started by me 25 years ago to develop a technology that would allow delivery of high-speed broadband internet into vehicles. Much like radios in cars, I believe firmly that one day there will be internet available in the cars. It was, of course, 25 years ago, and people thought I was crazy. But we persevered, and we developed some technology that is unique. And even today, this technology, especially today, this technology has took foothold around the world. And we have developed this product and sold over 10,000 of these antennas in 106 countries. So the company is relatively small. It has 33 employees. It's listed on the Toronto Venture Exchange under the symbol of CMI and on the New York over-the-counter CQB exchange under the symbol CYSNF. The stock closing price as of yesterday, after the disclosure of the financials, was $1.28. Today, I think it's up about 20 cents. The dividend yield on that closing price was 3.9%. And the market cap of the company is about $53 million, or was yesterday about $53 million. I, as a founder of the company, own about 40% of the company, of the shares of the company. I've never sold any shares, and I believe that the stock is severely undervalued because the technology that we have and the technology that we are developing is going to be tremendously valuable to the company over the next 3 to 5 years, and I hope that the stock will appreciate as a result of it. So just to give you a quick recap, the company has, as I mentioned, sold over 10,000 antennas in 106 countries. We keep the business relatively nimble and small and very profitable. We sell through dealers across the world. We have over 600 of them. We have over 40 different models that we manufacture, and we work with 10 different modem manufacturers as a plug and play, so that anybody around the world can just buy our product and plug it into the satellite modem that they are utilizing. It doesn't matter if it's in China or Russia or Mongolia. The antenna sizes range from up to 8 different sizes, from 75 centimeter all the way up to 2.4 meter. And we support different formats such as drive-away, fly-away, MAMPAC, fixed motorized. We also have 4 different bands that we support in the frequency band of satellite communication, which are Ka, Ku, C, and X. The working capital of the company as of the end of third quarter was over $25 million, almost $25.5 million. And shareholder dividends have been paid out as of August 31st to the tune of $19.545 million. So the company, as I mentioned, is profitable. It has paid out 42 consecutive quarterly dividends. It has 0 debt, does not borrow money, and it has a world-class technology that is appreciated and sold all over the world.
And just to sort of point out, given on from the prior slide and whatever the market cap is today, but market cap of $50-ish million, with $25 million of working capital, it's not given that, let's call it roughly 25 million for the business itself. So it looks sort of potentially even cheaper that when you look at your balance sheet with zero debt.
Right.
All right.
So the markets that we support or we provide product for are really pretty much where internet is being utilized. And to be remembered, this product is used in areas where internet is not available at all through normal means, or it's so poor that it's pretty much unusable. So we have governments, militaries, emergency response, disaster recovery, disaster management, oil and gas companies, telecom companies, banks, hospitals, schools, etc. We have many, many vertical markets where around the world where internet connectivity is desirable and has to be in some places mandatory, and it is essentially not available. And this is where our antennas come into play. So this is the map that shows the location of our antennas, our 10,000 antennas. Not all 10,000 are displayed on the map because some of them are behind the firewall, so you can see them. But the antennas actually communicate back to us, telling us where they are positioned through GPS. And so we can see them essentially on a map. As you can see, for example, New Zealand is packed from end to end because we sell a lot of antennas to fire departments in New Zealand due to disaster management. They have fires, earthquakes, and many other disasters where when the infrastructure is lost, there's no power, there is no communication, only satellite would be able to deliver internet connectivity. And so it is very heavily utilized by fire departments. The beauty of the antenna, of the robotic antenna that we manufacture, is that you don't need to know anything about satellites. If you know how to push a button, you know how to operate our antenna. It's designed to be a one-button solution. You push a button, and within 2 minutes, it locates the satellite that you are subscribed on and connects you to the internet. So that's why it is used very widely by soldiers, by mobile banks, by mobile hospitals, by disaster management, by cellular backhaul, and many, many other vertical markets.
So Leslie, I would not buy one of your satellite systems to bolt onto the top of my building or my house or something to get satellite internet connectivity. I would use it as like on top of my truck to drive out to a work site or an emergency place to bring internet to that location.
Yes, in most cases that is the case, but we do have them as disaster backup antennas on buildings, for example, of large companies like Costco and other very large box operators who require disaster recovery in case of loss of complete power in the building. So these antennas can operate from a battery, a car battery, and also from a generator. So for example, when you had the hurricane in Puerto Rico, Walmart and some of the other large box stores lost power. But they have a generator. Unfortunately, the generator will not operate a telecom network that's down. So what you can do is you can have one of these antennas on the roof driven by the generator and connect the cash registers to it to transmit over the satellite, to get the cash registers operational. Because even though the store has lights and you can have people in the store, if you cannot process the purchases, it's pretty much useless. And when you have no power, you generally have no internet connection either. So your cell towers are down, your communication is down, and only satellite is the way to go. So they are also used on roofs of buildings for these type of disasters. And also we have them with a number of embassies around the world on the roofs of buildings. They use different satellites during different times of the day, and they have multiple antennas to be able to access multiple different satellites, and they need to be able to do it with somebody who can push a button, because normally to acquire a satellite, even from the roof of a building, you have to point to it, and quite often it could take you 1 hour to 2 hours to point with instruments, and you have to really know what you're doing. You have to be a satellite engineer in many many instances to point it. So we have eliminated all of that by pushing a button. And so, but most of our customers have them on vehicles, trailers, all kind of portable devices that they need to haul or get to locations and deploy them within minutes. Like oil and gas companies have them on their trucks, and we have mobile banks that they have them in their large vehicles that are like ATM machines, and travel around and dispense cash. So the applications are limitless, but as you said, most of them would be on designed to be placed in places where you can move from place to place. Now, the way the antenna works is that you have to stop, push a button, and it finds the satellite. The new technology that we are developing, that we work with satellites that are moving, and also the vehicles that will be moving, the boats, the trucks, the planes, the trains, that will be a different technology, and that technology is being developed, and I'll talk about it in the next couple of slides. So this is a lineup of antennas that you can see. As I mentioned, they are driveaways which sit on top of a car. There are flyaways that you can carry in the back of a car with you, and within 5 to 10 minutes deploy it from cases that we have designed for them. You can put them together like Lego. There's no connectivity required in terms of no tools. It's all by hand. It snaps together, and you can put them together within 5 to 10 minutes, and you have connectivity. So you can bring it with you in many instances on the top of a vehicle, for example, so inside a vehicle in these cases, or the MemPack that's shown on the right-hand side is something that you can strap on your back, and it's about 22 kilos. You can carry it with you. It's carbon fiber, very light, and you can snap it together within 5 minutes and have connectivity. So you could bring it up to the top of a mountain. We have those antennas used for filming of commercials and other, video work that being done in remote areas of mountains where there's absolutely no connectivity, and they're able to transmit the video instantly into the studio for editing. Now, sorry, go ahead, Martin.
What is the ballpark price? What is the range of price on these units range from?
The range of price is about 15,000 to about 80,000.
Okay.
So they range, the lowest cost unit would be about 15,000 complete, and the upper end would be the flyaway, the 1.8 meter flyaway that you see there, Fly 1801, which is a fairly large package used for helicopter transport for very large bandwidth requirements in the remote areas where you need a 1.8 meter antenna to deliver a decent amount of broadband for the customer. Now, the heart of the system is the controller that's shown there. That is actually the one-button controller. It's a very sophisticated, probably the most advanced controller in the world, that with a press of a button finds the satellite. Now, interestingly enough, as we talked about the roofs of antennas, there is also another generation that we've developed called the fixed motorized antenna, which is shown on the bottom here. These antennas are used in very remote areas of Canada, Russia, China, and islands where you have unattended requirement to deliver broadband. So these antennas are physically mounted either on the roof or on the ground, and they are able to automatically correct themselves in case of an earthquake, for example. If the ground shifts, the antenna will repoint itself. Also, if you have tremendous winds and they dislodge the antenna, then they will also repoint themselves. So these antennas are used in areas where it's very hard to get to, and you may need an engineer to fly in and spend 3 days to just repoint the antenna when you lost signal. And we have quite a few of them in different parts of the world where these are remotely operated and are able to automatically reconnect in case of a mishap where the antenna loses signal. So these are the three different and the MemPack are different models that we sell.
So just on some satellite antenna basics, the smaller the dish is, the lower the bandwidth would be. You can collect fewer radio waves or signal out of it. So the bigger it is, you collect more and can transmit more. And then the smaller it is, the cheaper it is because there's less stuff it's doing, and the bigger it is, the more expensive it is.
Yes, that's one part of it. The other part of it is that in some parts of the world, 80% of the coverage could be, let's say, a 75 centimeter antenna, but on the fringes of the beam, you need a larger antenna. So you may have to go to a 98 centimeter or a 1.2 meter antenna. And some customers say that if they have to cover the whole area that they are covering, they rather have a larger antenna that covers everything than have two different types of antennas where one would cover 80% of the area and you need something for the other 20%. Now, yes, the larger the antenna, the more signal it can pick up, and the more fringe areas it will also work in. The amount of bandwidth with a smaller antenna depends on the frequency. If you have, for example, the latest generation Ka band frequency, those antennas tend to be smaller, their transceivers tend to be less expensive, and they tend to deliver much more bandwidths. So you have different satellite services, different frequencies, different antenna sizes, and they all make up the most optimal use and the cost of both the service and the hardware.
All right, on to the next slide.
Yeah.
Oh, there we go.
So we can go through quickly here just to show you how we economize the design. We build one antenna that will support, for example, the G would be a GILAT approved type of service. The V would be a Viasat approved type of service. The H would be a Hughes, YACLIC, and many other type of services. So we can, depending on the type of service the customer is looking for, we can sell in the same antenna with a different configuration. So we can cover a whole bunch of different applications that the customer is looking for with the same antenna, the same controller. We just have to define the type of service, the ground service that he is offering. So these would be different modems, different transceivers, but the same antenna.
All right.
So it's just the same thing, different products. Here you can see a broadcast type antenna that folds down to an aerodynamic sleek pod. It has, that's called like the wind deflector. It's used pretty much for broadcasting, for transmission of television signals from remote locations.
So like on a news truck, it rolls up this way, it doesn't get damaged or it doesn't cause too much drag, and then you'd pop it up when you're at the news site. That's
correct.
All right.
This is the flyaway we talked about, the different sizes. This is the 1.2 meter. This is the MEMPAC. So you can see that whole system on the tripod and the reflector just pack into that one case, and you can carry it with you. We sold about 400 of these antennas over the last year and a half. About 250 went to SoftBank in Japan that is used to replace cell towers. So this is a cellular backhaul solution, a 1 meter antenna that allows, when you lost your cell tower, to become a cell tower. And
okay,
somebody can carry it with him to the location where the cell tower is down, have power applied to it, and then they can connect to the cellular tower that they have attached to it, and then it becomes a cellular backhaul. So essentially, it replaces the destroyed tower until the tower is rebuilt.
Gotcha. All right.
And so it just shows more of what it looks like. Then the controller, again, is just one button. So anybody can take it out, anybody can operate it. Anybody can snap it together. The reflector clips together, so there's no tools. It's very simple to operate. And this is a military version of it that we are just designing for a customer who hopefully will purchase a couple hundred of them, and they want it in a mil spec, mil style color. So this is probably what it's going to be look like. It has a Wi-Fi built into it. So once you are connected to the satellite, you can use Wi-Fi within a kilometer or two from the antenna, around the antenna also.
And mil-spec, it's a little more waterproof, shock-proof.
Yes.
You can drop it more and that kind of a
That's
thing.
correct. It's made a little more rugged than a regular commercial antenna. It will be more expensive also.
All right.
And so here are some typical examples of disasters where this antenna, as you can see, it's deployed there on the ground in Japan. There's a person carrying it up into the flooded area, and another larger flyaway antenna being put together there in Japan also for disaster management. So these are different applications for oil and gas. You can see them in different parts of the world, in Australia, in Texas, in China, in Libya, and in the United States.
So is it fair to say that a lot of the, obviously oil and gas and mining, but it seems like on the map, it was really spread out all over the world. So a lot of developing nations or growing economies where maybe they don't have as much fixed infrastructure, they're bigger users of this than the more developed economies. Is that fair?
Interestingly enough, if you look at the map, you can see that the largest population is not in Africa and in Australia and in Mongolia. The largest population is in North America and in Europe.
Okay.
So that tells you that the amount of bandwidth that's required instantly is just not available to most of these people. So this is a solution. For example, in London, the fire department has probably 30 or 40 of these devices on their trucks, because if you have an explosion in the downtown London area, you lose power, you lose connectivity. So it is far more. And it's far more used in the developing countries in that type of an application than in the less developing countries. So the less developing countries would use it maybe for military applications. The more developing countries would use it for these type of disasters. For example, in Ottawa, we also have a couple of fire trucks that have these antennas for hazmat type of applications, where they are able to deliver high quality video from the truck in case they go out to areas where there's no connectivity of any kind. So you want to go there with the idea that you can stream video if there's a big fire or there's a major disaster, regardless of where you are. So the applications are limitless. And as I said, quite often, just to give you another example, you have a concert where there may be 100,000 people. The cell company would be overwhelmed by the number of cell phone users in that area. So very often they would drive out one of these antennas and route all the concert traffic through those antennas back to their hub, because that would alleviate the congestion of the people who are living in the area.
All right. Well,
so news gathering, we talked about this. These are examples of pictures of news gathering. This is emergency response we talked about. You can see fire departments and health, telehealth. We have mobile surgeries, mobile disaster management. We have military pictures. We have cellular backhaul, telecom pictures, again, of how they're used, where they're used. This is an interesting one. It's the mobile offices, what they call e-government type of applications. In South Africa, we have 120 units with the government of South Africa for pensions. So they print pension checks remotely. They go out and deliver the pension checks from these vehicles. In Argentina, they print passports and IDs, again, remotely in different areas of Australia. So that the people who need them don't have to come into the city to get the IDs. They are delivered to them remotely from these vehicles. We also have mobile tax offices, mobile banks. As you can see, there's quite a number of them. And then if you go to the next slide, this is the new area that we are entering. It's becoming extremely hot market, and these are what we call the golden age of the satellite business. Elon Musk with SpaceX, OneWeb with the UK government, Amazon Kuiper with Bezos, Telesat, Boeing, and everybody and their mother now are in the satellite business. And this launching of low Earth orbit satellites, or LEO satellites, which all these people are doing, will generate over 10 to 15,000 new satellites in the next couple of years. And they will be delivering or covering the whole world and delivering bandwidth to the rest of the population. And the antennas on the ground that we have started developing 5 years ago for this market are going to generate up to $17 billion of opportunity to support these type of applications around the world. And so if you go to the next slide, CCOM has developed this very small antenna. You can see it. It's compared to a Canadian quarter. You can put these little squares 16 antennas. There's 16 antennas on that 4x4 chip, and it's an 8-channel product that when you combine it together, you can build up an element, a 1,000 element or a 3,000 or a 4,000 element antenna. So technically it's 4,000 antennas that can be steered electronically and look for the satellite regardless of where the satellite is. And most of these are used for satellites that are in low Earth orbit, which means that they are, the geo satellites, which are geostationary, that don't move. So it's relatively easy to locate them with the antennas that we have developed for vehicles, because you always have the satellite in the same position vis-a-vis where you are. The new low Earth orbit satellites travel at a significantly lower orbit, and they travel very fast. And so you have to be able to track them and drop off one and pick up another one as they come up from the horizon. So only way to do it is through these electronics antennas, which are no longer parabolic antennas. These are electronic antennas. They're like a printed circuit board, essentially, and they are thin, they are light, they are small, and they deliver a tremendous amount of bandwidth with these low Earth orbit satellites, like SpaceX and Kuiper and many of the others, the telesats that are going to be launched in the next couple of years. And this market will be representing about, over the next 5 to 8 years, about $17 billion, a $17 billion opportunity.
So these modules, you take one of those that's the size of a quarter, and if you want to make a small, medium, or large full antenna, you just sort of plug more of those in together to get your different sizes. So it's a modular system, which I would guess sort of reduces the cost or simplifies the manufacturing of it.
That's correct. You can build millions of these little squares and then just build antennas up to depending the bandwidth requirements of the customer. So you can build a 1,000 element, using 16 by 16 4x4 modules, or you can double it or triple it or quadruple it, depending on the amount of bandwidth that is required. And not only that, these antennas are easy to put together, relatively easy to put together, because they come together. It's called like a Lego concept. But you can also, they're conformal. So you can actually build them to different sizes, different shapes. You can tile them, to the fuselage of an aircraft, etc. So they have some tremendous advantages over the physical parabolic antennas, which are fairly large. And just to give you an idea, let's say a 75 centimeter parabolic antenna would be replaced by a 60 by 80 centimeter electronic antenna that would be about 5 centimeters thick, and it would be able to track multiple satellites simultaneously, compared to a parabolic antenna that you need 2 of them to do the same thing, because one would have to carry one signal, and when the satellite disappears over the horizon, the other one would have to pick it up and carry it, and it's a rather complicated process. So these antennas will ultimately be used for 5G, 6G applications, and also they would be used for IoT applications, because they could be made into very small modules, inexpensive modules, to be used for IoT applications and used for collecting of data, or used for agriculture applications, and many other applications where satellite connectivity and the antenna will combine this product to be very, very interesting and very useful.
So are these essentially semiconductors that are built in a traditional semiconductor fab, or how are they manufactured?
They actually, the back of these antennas there's chips, 4 chips on the back of it. So they are integrated circuits on the back of the antenna, and those are radio frequency integrated circuits that do all the software, all the transmission, reception, and we do the beam steering of these antennas electronically through software.
I don't want to get too technical here, but obviously you've got to point to in the general direction of where the satellites are going to be. How many degrees of angle can they like electronically adjust? Like, what is their sort of sweep across the sky?
Yeah, you don't have to point them. They will automatically find the satellite, and they will go down to 30 degrees on each side. So they will go from 30 to 30, and beyond that, you lose quite a bit of gain on the antenna. So you may have to, if you go below 30, you may have to either do a mechanical tilting of the antenna to allow it to see below 30 degrees. But most of the satellites, most of the areas that we would be covering would work well within the 30-degree angle, 70 degrees, depends how you look at it.
Okay, so you just point it in generally the rough direction, and then it should be good.
Well, it has a compass, it has a GPS.
Yeah.
You don't have to do anything. It's essentially you will push a button or you start your car or whatever. And if you have the proper modem, for example, connected to it, it will know which satellites to look for, which frequencies to decipher, and will connect to the appropriate satellite flying overhead.
Gotcha. I'm just going to switch back to this one. When I first was sort of investigating and looking at your company, I like, especially since the whole Ukraine situation and the Starlink, is like, oh, those big which are relatively small compared to 40 years ago or whatever, but your relatively big satellite parabolic dishes, like they're going to be replaced by like the Starlinks and so forth. Is this more of a, like, is there an opportunity for your existing products in this new world of the micro satellites, or is that business going to get sort of swept away and replaced by your phased array flat semiconductor antennas?
You mean the existing business?
Yeah.
No, because there are really literally thousands of geo satellites up there, or the lifetime of which is 15 years. The satellites that Elon Musk is putting up have a lifetime of 3 to 4 years. So people who have invested in those large geo satellites will continue to use them. So we will be able to use those as well, using our antennas, electronically steered antennas, because they will work on stationary geo satellites. They will also work on medium Earth orbit and low Earth orbit satellites. So our antennas, existing antennas, will continue to be used. They will hopefully be less expensive for a while. And some customers who don't care about size and they don't want to work with low Earth orbit satellites would be happy still using our geostationary satellites, but our parabolic antennas for use of geostationary satellites. But ultimately, the electronic business will overtake all of that. So it will take a long time, I think, but it will ultimately, you will have electronic antennas that will replace the parabolic antennas for sure. How long it may take, we don't know. But that's why we started working on it 5 years ago, because we know that this whole business is shifting. And we have to be able to shift with it along and have the technology ready for it to work with all these new satellites that are going up, and there'll be tens of thousands of them.
So how is the technology you're working on, whoops, wrong way. How is this technology different than the satellites that Starlink, those little flat square antennas that Starlink is putting out? Where is your revolutionary or a disruptive change in the technology?
First of all, the ones that Starlink is using are designed for consumer markets. We are not addressing the consumer markets at all. We are only interested in the commercial markets. Secondly, the Starlink technology is Ku band, which is about 100 times less powerful than the Ka band. So most of the next generation, like Kuiper and Telesat and Boeing and all these others, are going to be Ka band. So our antennas are designed for Ka band. It is much more difficult to design the Ka band antenna, electronically steered antenna, than it is a Ku band antenna. And also the mobility aspect of it, the full mobility aspect of it, is something that we have. And I know that SpaceX is also working on some mobility, but it's again in a different frequency band than ours. Plus their service, their antennas are unique to their technology and their service. Our antennas will work on anybody's Ka band service. So that would make it different. For example, we'll be able to sell them to Korea or to Europe or anywhere else on a generic satellite service. SpaceX will provide only service on their own service platform with their own specific antenna system.
Gotcha. All right.
So this just shows how small that 4x4 element is, and it describes the conformal ability, the scalable ability, and ability to scan 360 degrees electronically. But technically, once you put it all together, it will only operate very efficiently between 30 degrees so the lowest it will go is 30 degrees.
All right.
And this is how you put them together. So you have 4x4, 16x16, 80x80, and then you build different sizes of them. As I mentioned, it's a Lego-like construction. And so we have multiple patents on the design. We are also working with what we call a dielectric-based phase shifter that shifts the signal during the transmission and reception, and it's something that we developed at the University of Waterloo, and it's what we call a passive component that would replace the integrated circuits on the board with some very inexpensive, low voltage required components that would make the antenna much less expensive than using integrated circuits. So this is a technology in progress. It still has a couple of years to go before it becomes something that will be developed. Now, this type of an antenna would be on the roof, could be on the roof, because it would be very inexpensive, would require very little power, and it would work rather well, not probably as well as an integrated circuit-based antenna, but it would still work very well, and would be relatively inexpensive, and it could be flat, thin, and also track multiple satellites as they pass over the building where it would be installed.
And so this is sort of the next generation. This is different technology than what we just saw on the previous
That's
slide.
correct. It is different technology.
Gotcha. Oh, wrong way.
So this is just gives you an example of the receive transmit panel compared to a parabolic antenna that was being tested at the University of Waterloo. So you can see those panels are not exactly the same gain that that parabolic antenna would give you, but you can still see the difference between how robust the parabolic antenna, how heavy and massive it is compared to a phased array antenna.
And just to point out, it's not just the parabolic dish; it's that antenna or whatever thing sticking out in front of it.
Of course, the whole thing. That's the feed, the transceiver, the whole thing. It's the whole the feed arm and everything else.
Yeah.
So here it just gives you a little bit of an antenna analysis of the total flat panel antenna shipments that are expected. Some of them are shipping today, like the SpaceX probably is in there at 30,000 as flat panel antennas, but you can see how it will be changing dramatically over the next 3 to 8 years, and it will be an extremely large market. If you look at the next slide, it will show you that it will reach it will reach 25% of all the existing antennas shipped today. So it will be representing actually in about 2 years about 4 million flat panel antennas. So and it will be about 6 million by 2031. So that's a lot of antennas that will become electronic antennas. And so this is our product. We actually developed it, tested it over Telesat last year. In March, we showed it at the satellite show in Washington, D.C., and hopefully we'll be delivering and exhibiting in March the larger version of this, which will be the final product that we will go into manufacturing with. And this is a product that would be sitting on top of a vehicle.
So this is the antenna that with all the little modules that go 4, 16, and
Yes.
but it's underneath a plastic casing and whatever.
Yes.
So you've got a proto. I don't know. Is this a prototype or beyond a prototype? But this is a
functioning prototype of a 1,000 element antenna. So this was tested over satellite to verify that it works as expected. And what it was missing is full mobility, which is being added to it now so that it can be actually put on a car and driven and utilized in full flight with these low Earth orbit satellites. At the same time as you are driving the car, you are able to deliver high-speed broadband into the car.
So it's not just, it slowly tracks. It's like I'm driving along a road and the little
it's electronically tracks. It's not slow, it's very fast. It switches between satellites in milliseconds.
Okay, and it switches between, I do a sharp left turn and it's able to track the
That's correct.
Wow.
That's correct.
Okay. So the official product launch on this is in the spring, let's say?
We expect it next year. I'm not sure exactly when because we lost some time. The university, the labs were closed during COVID. They were not, the developers who worked there were not able to go into the labs so that we lost some time. We should have been ready by now, but I would say that we will be doing satellite testing early next year and verifying that everything works with the next generation of this product, which will be four times larger in terms of antenna size, and not physical size, but antenna size. So this is a 1,000 element, and we are now finishing a 4,000 element array, which will deliver much more bandwidth and will actually replace a 65 or 70 centimeter parabolic antenna.
Well, and this will work on the Ka band, I believe, from
That's
reading
correct. That's
on all your existing
all
satellites.
Existing Ka band satellites, yes.
Okay, so it'll be able to replace some of your parabolic.
Yes. Those who will want mobility on a Ka band antenna with a Ka band antenna, and they will want it in full motion, will be able to use this.
And are you the first to market with one of these products?
I think we would be one of the first ones with full mobility of a Ka band antenna of this size and this performance. But it's hard to know because there's multiple companies working on this, but nobody has released anything. So we don't know who has what, but we will probably be one of the first to have something. There'll be a cost advantage, we hope. There'll be a size advantage and a performance advantage with this type of an antenna.
So I guess looking at the market from here, what is your market position on the current portable, your current product line? Are you the world leader, or are you in the top 10 market share, or where do you stand?
I would say that on the commercial side, we are the world leader. On the overall side, we may be the second largest in the world. This market, the one that we are in today, is not such a very large market. I mean, you can see our sales, hit about $20 million a year. So it's a very niche market, very profitable, but very niche market. And there are companies that only work this type of technology that we presently sell, the military market. And that market is larger than the commercial market, but again, it's mainly US. So US-based companies, addressing the military market. And we are not playing that market with our existing product. We are in the commercial space.
So the market dynamics in a fairly small niche market are different. Because as they become cheaper and work better, and you can use them on real mobility, and you've got some huge players there. It's different to be a leader in a niche market than it is in a huge mass market. Are you going to have to change your strategy or your approach to how you conduct business to maybe you even have the better technology, but you get left behind by the guys with the more market weight?
Well, it will depend. It will really depend on who will come up with a similar product with similar capabilities, similar pricing, similar flexibilities that we have. And also, I firmly believe that the technology is going to be so valuable that somebody may want to buy it.
Okay. And what is the rough ballpark? You can't let too much out of the bag, but kind of what price-ish would this be sold at?
I would say initially you have to consider it to be an expensive product, but not as expensive as some of the people who are selling these to the government and to the military. So those antennas are in the hundreds of thousands of dollars.
Yeah.
This antenna would probably end up being, I would estimate, between $30,000 and $50,000. And so
Okay.
again, it is a niche market where similar to what happened to the cell phone market. If you remember, a cell phone was $3,000 or $4,000. It was large. It contained a power supply and you had to carry it in two hands, etc. The technology ultimately, with volume, changed and became down to where you can put it in your pocket. This technology will also go through a similar transformation, and volume will dictate the price of the antenna. So if we can build these in tens of thousands or hundreds of thousands, the price will come down to less than what the parabolic antennas are today.
And I guess yours will be more of an outsourced manufacturing model where maybe you do the final assembly, but I presume you're not going to be building your own integrated circuits in that. That's something for those specialists to do.
Well, we have actually designed some over the number of years that we have worked at the University of Waterloo. We have designed a number of integrated circuits that we have patented also, and those are available. But we are not going to get into the manufacturing of integrated circuits. We are going to outsource, just like we're outsourcing today. We don't build anything today. So we build 200-300 antennas with local outsourced manufacturers. And that's why we can stay small. We are only 33 people because everything is outsourced. We don't build anything ourselves. We design, develop, test, but everything is outsourced. So this would be the same thing. We are actually going through the process of finding an outsourced manufacturer who can actually do something like this for us without us doing anything other than continue to develop and enhance the product.
Okay, so you'll be the research, development, product design, outsourced manufacturing type company.
That's correct.
And I guess that's essentially what you are right now.
That's correct. That's what we do exactly today. Yes.
Okay. All right.
So this is what it looks like on a car. You go to the next slide.
And then, as you were saying, like future generations, that's probably just going to get smaller and smaller and cheaper, and then it'll just be like a GPS unit on a car or something.
A car. That's the whole idea, and that also will depend on the evolution of satellite satellites themselves that are developing the service, because we have to live with the requirements that the satellite needs in terms of physical size of the antenna on the ground to communicate with the satellite.
All right.
That's what would look like on a train and on a plane.
All right.
So we are also developing an interesting application. We have received funding from the European and the Canadian Space Agency, and we are working with a number of semiconductor manufacturers, US and European, to develop a chipset and a communication between a UAV or what they call HAPS, which is a high altitude plane that could travel up to 3 months at 20 kilometers over an area that has no cellular traffic and communicate up and down to deliver cellular communication to users on the ground without use of cell towers. So the antenna on this HAPS would be working up and down with a satellite, as you can see, and the chipsets and in the antenna that we are working with the companies that are developing it would communicate up and down to an area of up to 400 kilometer radius, communicating with cell users who don't need a cell tower.
So basically 5G at the bottom with a big antenna at the top communicating to the satellites.
Right.
All right. And okay.
And so these are the partners. So Skyworks from Canada, NXP Semiconductor in Holland, so the companies are Canadian and Dutch, and the funding is it's called 5G plus or 6G, and the funding has been allocated to us by the European and the Canadian Space Agency, and it's in the next generation higher frequency than KA. It's what they call V-band, the V-band frequency. So you'll be able to deliver 100 times more bandwidth in that frequency than you are delivering in KA.
And just like NXP Semiconductors, that's a very large semiconductor. So you've
Yeah,
got some big partners there.
so is Skyworks. Yes, they're billion-dollar, multi-billion-dollar companies.
Yeah, yeah.
So it just tells you basically what this concept is, and you can see a link there. If you click on it, SoftBank has developed this plane, and you can see the concept, how it works, and the whole idea is to eliminate cell towers. They're about $1 million each. So if you have a 400-kilometer area, you may need you may need a couple hundred of those, and if you can deliver this type of a solution and save a couple $100 million, it's definitely something worthwhile to consider.
Yeah, and then so much open up all sorts of new markets for communication.
Exactly, where there's no cell tower, or people would never put in a cell tower because the number of users is not justifiable.
I'm just noticing something here. I see the word latency there. When you go through satellites, is there a much latency added to the whole process where you notice it? Let's say you're playing video games or something and you need low latency stuff, or has that problem been kind of solved?
Well, it has been solved on geo satellites to some extent, but the latency becomes worse the higher the satellite in orbit is. Yeah. So that's why the low Earth orbit satellites have virtually the similar latency, or a little bit higher than what you have in terrestrial communication. So if you are flying at 300 to 400 kilometer heights compared to 30,000, you have definitely a much lower latency. And so that's why the whole concept of low Earth orbit satellite will be that you'll be able to have the same latency as you have with fiber optic cable. So yes, there is a problem with latency with geostationary satellites, but less so with low Earth orbit satellites.
All right.
That's it. Go.
All right. Just a couple of points maybe we didn't catch. On your last financial statements, COVID hit you guys. Some of the things that I just like to quickly hit upon. With COVID, your business was slowed down like many, although you'd think with the need for communications, it would have been increased, but just the deployment, I guess. Could you talk about your supply chain inflation and just sort of what happened over COVID with your business?
Well, over COVID, what happened was that we obviously could not go to any trade shows. We could not visit customers. A lot of the funding that was allocated by governments, for example, for this type of technology, was delayed or used for COVID type applications or COVID requirements. So definitely everything slowed down, not because there were supply chain issues, because the economy actually slowed down in many ways. So we started seeing, as this year, starting with the new year, and the resurgence of business because of the relaxation of the COVID rules. On the other hand, there are major issues with supply chain and also with cost involved in shipping. They went through the roof. So fortunately, we have a very large inventory. We have an inventory of about $7 million. So the advantage that we had this year, that while many of the competitors that we had, some of them already have left the business, but the others that have been around could not deliver product because they had no parts available. So fortunately, we had hundreds and hundreds of antennas built in 2019, and so we were able to deplete them until today, and able to have completely eliminated the issue of supply chain. And also we started buying long lead parts early on this year for the next production, which started to roll in today. So we are not seeing any issues with that, but many companies are. We can ship product in weeks other than many, many months that other companies are quoting. So we have a huge advantage over that.
In the last quarter, your revenue was, call it roughly $2 million compared to roughly $1 million the year before. Last year's was suppressed because of all the COVID stuff. Is this year's overly high? Like, are we expected to see like maybe 2 million again next year? Will there be a bit of a dip or continued growth through that? Can you give, without being too specific, can you give sort of a trend?
Our business is very lumpy. So we may have an order that comes out of the woodwork for $5 million tomorrow, and it will totally skew the the quarter from quarter to quarter. But you can expect that, going back, hopefully next year also to hit the high numbers that we have are going to be hitting this year. So definitely we will be in the, over the 10, 12 million dollar sales and a profitability that will continue just like it was 2019, for example. So we don't expect a dip.
So, okay. So on a quarterly, you could be lumpy, but on the more annual or trailing 12 months, that should be a steadier kind of growing trend.
That's correct.
All right. And when any guesstimates or insight you can give us on when you think the new generation of antennas are going to start making, let's say, a meaningful impact to the financials?
I would hope that towards the end of next year, there will be something, but it's hard to tell. I mean, it's hard to know what other obstacles we may hit in the final stages of this, but I expect to have a product. And also, we are working with a number of vertical integrators who work, let's say, for UAVs and the military, and they would want this antenna to be customized for their requirements. So we would expect also some revenue from customization of this antenna, or from the sale, just the raw antenna to them to be built into their own products that they are developing, some for the military, some for specific communication requirements. And so we are hoping that the antenna, the new antenna, will start delivering some financial returns to us next year.
All right. And I think my final question here is, you right now you're getting gross margins that are above 50%. Your new product lines, are they going to have similar kind of margins, or are they going to be, and I guess maybe as you get bigger, you get economies of scale out of it. So it'll probably change as you grow, but can you, any relative guidance on those gross margins?
For now, I would say that they would be the same. There's no intention of reducing those margins, and the pricing is done based on keeping those margins up there. Gotcha.
All right. And well, it's been pretty full interview here. Is there anything we kind of missed that you'd like to highlight before we wrap it up?
No, I just think that the markets we're going into some turbulent times, and the stock obviously is been decimated as a result of it, brought down to about half of what it was a year ago, and yet we have done much better than a year ago. And I believe that the stock is undervalued severely, as you mentioned also, and it's a good time to buy. That's it. The dividend is a great return to the customer. We have a lot of cash. We have no debt. It's a very, very unusual situation for a technology company. We are not looking for money. We are not borrowing money. So it's a very solid company that we are running here.
All right, Leslie, thank you very much for taking the time to chat with us. That was very informative and a lot of fun. Thank you.
Thank you very much, Martin, for having me. And if you have any questions, if you're any of your customers, they have my email, and I'll be happy to respond to them.
All right. Cheers.
Thanks. Bye.